Good afternoon, everyone. Welcome back. Today we're going to start with the theoretical distributions. Last time we have studied probability, and before that we have talked about central tendencies. And so now what we are going to do is we are going to try to map this probability distributions onto the frequency distribution. So let us dive into it. Yes, good afternoon, Ishan, Bhargavi, Praveen, Lakshita, Bhumika, Rafika, Nikita, Sonali, Bibu, Jyoti, Avdesh, Rohini, Jia, Swati, Maidha, Sarvesh, Divya, Rekha, and Soumya. Okay, so welcome. So now we're going to first talk about the theoretical distributions and the importance of it. Okay. Now, what do you mean by theoretical distribution? So, like we have the frequency distribution, what do we do is that we find out the frequency. We have discrete variables, or we may have continuous interval, and for that, in that we are finding out the different frequencies of the event occurring. Okay. So, how many times that, like suppose we are tossing a coin, so how many times we are going to get a head? Now, what is happening here is that, like we distribute the total frequency, now here we distribute the total probability. Like in frequency distribution, we are distributing the total frequency. Here we are distributing the total probability to different mass points in case of discrete variables and different class intervals in case of continuous random variables. Okay, same thing like we did for frequency distribution. Like we had class intervals, we made them continuous, and then we had the frequency distribution. Similarly, for probability distributions also we have similar things. And then these are known as theoretical probability distribution. Why do we call it theoretical? Because they exist in theory only. So, but why do we need to study this? Let us try and understand. So first is that the frequency distribution is going to give you the number of times the data point occurs. Okay. But what does the probability distribution give you? That the probability that the data will occur, that data point will occur, is given by the probability distribution. Okay. So frequency distribution gives us the number of times that data point will occur, but the probability distribution will give us the probability that that data point will occur. Second thing is, it is used for short-term projections for the future. So that is why studying this is important, because it helps us to predict the short-term values. Projections means values for the futures. The third important thing is that statistical analysis that we do on the data, like we have the raw data, then we have the frequency distributions, and then we try to find everything about it. Like we have the mean, median, mode, like geometric mean, harmonic mean, those type of things. And then we analyze this data. Okay, after finding all this, we try to analyze how the data is moving, how the data is going to behave under certain situations. Then we will we'll be doing later confidence level, then statistical hypothesis. So you don't have to worry right now about this, but we are going to do it in the second and the third lecture. Okay, so all these things is going to talk about what the population parameters. Okay, these population parameters is based on the probability distribution of the population under consideration. So statistical analysis is possible only when we have done the probability distribution. So what are the three reasons why we need to study the theoretical probability distribution is? First is that the frequency distribution will give us the number of times the data point will occur, but the probability distribution will give us whether or not that data point is going to occur, or what is the probability of it occurring. Second thing is, using this theoretical probability distribution, I can give short-term projections of the for the future. The third is that for statistical analysis, we need the probability distribution. Okay. So what we have done for this thing, for our data, for our frequency distribution, like we found the mean, we found the median, we found the mode, that is the measures of central tendencies. Similarly, you can find these values for your probability distribution. So this probability distribution will have a mean, will have a mode, okay? So that is possible. Again, like we have in frequency distribution, we have discrete probability, discrete frequency distribution, and we have the continuous probability distribution. For discrete, we have two types of discrete probability distribution that we are going to study is binomial and the Poisson. And for continuous, we are going to study the normal continuous distribution. Okay, normal distribution. So binomial and Poisson is for what? These are a discrete probability distribution, and normal is a continuous probability distribution. Now, just talking about the binomial distribution. Binomial distribution is applicable where the trials are independent. This word is important. That can be a theory question. And each trial has just two outcomes. Okay, each trial has just two outcomes. Okay. Wherever you have such situations where the trials are independent and the trials have only two outcomes, either a success or a failure. What you define as a success and what you define as a failure is depending upon the question that you have. But if the trials are such that you are getting only these two options, then we say it is, then we use the binomial distribution there. So all the coin tossing experiments, we are using binomial distribution. Sampling inspection plant, we are using that. Genetic experiment. So that may be a theoretical question, like in genetical experimentation, which distribution do you use? So you can say you are using binomial distribution. Okay. So main thing we should remember is for binomial, the trial should be independent and there are two outcomes, success and failure. So we have theoretical distributions. That we are going to study. In that you may have discrete probability distribution and you have continuous probability distribution. And discrete, we are going to study the two types. Those are binomial and Poisson. And in continuous, we are going to study the normal distribution. These are the very famous ones that have a lot of practical application and that are very commonly used. Okay. So theoretical probability distribution, we are talking about discrete probability distribution in which we have binomial and Poisson, and continuous, you have the normal. Now, before we go into what is the binomial distribution, yes, Soumya, Vanshika, Arisha, Chahal, Anushri, Bhavya, Sagar, Rabish, Manshi, Kirti, Zeba, Rahul, Abhinav, Neha, and Diksha. Yes, Ustad. Yes, Ustad, this chapter is connected with probability. Okay, yes, Shivangi. So, Ustad, you can watch the videos of the earlier sessions. Two sessions we have dealt with probability. So, you can go to that. Now, coming back to binomial distribution. So, to understand binomial distribution, we must know what are Bernoulli trials. Okay, so everywhere in the book you will see whenever you have binomial, the word Bernoulli is written over there. So what is Bernoulli trial is that it is the independent identically distributed trials. Okay, independently means what? That one trial is independent of the other trial. Identical because, like, suppose I'm tossing a coin. This experiment is there that I toss a coin. So what happens when I toss a coin? There is only two possibilities. One is a heads and the other is a tail. Okay, so I am using the same coin. Okay, so that it is identical and distributed. So independently identical distributed with outcomes as 0 or 1, that is success or failure. So I may consider heads as a success. So when I say that heads is a success, and then the other will be tails. Tails will be equal to a failure. Okay. It has nothing to do with the English word success and failure. It just means that when I toss a coin, I am getting a head or not. So when I get a head, I say that my experiment is a success. When I get a tail, I say that the experiment is a failure. Now, this happens when we do it once. Okay, so we are talking about Bernoulli experiment that we are doing, trials that we are doing once. So when I do this, when I take it to more levels, like when I'm involving n, that is that I'm doing this experiment over and over again, or I'm using the more than one coins, then we say, then we have the binomial distribution. So in binomial distribution, again, it is many Bernoulli trials done together. Okay, so the same concept is there, that outcomes are only two, that is success or failure, and then all the trials are independent, identically distributed. This is that is the outcome of one is not affecting the outcome of another. So that if I toss the coin 1, it is not going to affect when I toss it again. Okay, so that is independent of each other. So every time I do the experiment, it is a fresh start. It has nothing to do with what happened earlier. Okay, so let us see what are the features of binomial distribution. So each trial is associated with, see, very important, 2 mutually exclusive and exhaustive outcomes. Exhaustive means once I consider those outcomes, nothing else will happen. So what are the 2 mutually exclusive? Just remember the experiment of coin, getting a head or a tail. So they are mutually exclusive, right? That is, getting a head is not dependent on getting a tail. Okay, so there are 2 different things and there is no overlap. That is, I may get a head and a tail. Does it happen with a coin? No, right? You will either get a head or a tail. So they are mutually exclusive and exhaustive. That is, when I toss a coin, nothing third thing can happen. I cannot get a head on a tail and a 7. Okay, I can't have that. Okay, so I will get a head or a tail. So there are 2 mutually exclusive and exhaustive outcomes, the occurrence of which, okay, the occurrence of one of which, you define what is a success and its non-occurrence. So its non-occurrence is called as a failure. Okay, getting a head is a success. So when I get a tail, what does it mean? I did not get a head. Okay, I say I did not get a head and then I term it as a failure. The trials are independent. Okay. The probability of the success is usually denoted by P. So remember this. This is a very important symbol, that P represents success and Q represents failure. Okay, so P is the probability of success, Q is the probability of failure. Okay, and what is the relation? P plus Q should always be equal to 1. Why this one? Because they are exhaustive. This is very important. Okay, because they are exhaustive. So P plus Q is equal to 1. So we write Q is equal to 1 minus P. And if Q is given, then I will write P as 1 minus Q. Okay. So just remember this. And the number of trials is a finite positive integer, so that n is greater than 0. Okay, finite positive integer. So if n is 0, there is no point, there is no experiment. But when I'm doing an experiment, so it can be 1, 2, 3, 4. So n is a positive number. How many times I do the trials is the trials are independent. The trials are finite positive integers. In Bernoulli, we have in binomial we have 2. That is, each trial can have a success or a failure. The trials are independent. The probability of success is represented by P and the probability of failure is represented by Q. And the number of trials is a positive, finite positive integer. Okay. So I've just taken down two sums, two MCQs from the exercise. A trial is an attempt to. Okay, so this theory, once you do this theory, you should be able to answer this. A trial is an attempt to A, B, C, D. A is make something possible. B is make something impossible. Trial, prosecute an offender in a court of law. See, we are not dealing with this. Okay, we are not dealing with this. Here, we are here talking about trials in statistics. We are not talking of trials in a court of law. So that is nothing to, that is not related to us. So among A, B and D, can you tell me, quickly put in the chat box, what will be the answer of 7? Yes, Amina, Nital, Isha. Yeah. Good afternoon. No, Nikita, why there is 1 and 0 is not. When there is 1 and 0, you apply binomial. You can't do it depending on your experiment. When your experiment has only 2 outcomes, you use the binomial theorem. Yes, Rohini, Bhumika. Yes, Lakshita, it is D. Avinash, D. Okay. Yes. Kirti, Samina, Sakar, yes, it is D. So, we have already run the produce an outcome which is neither certain nor impossible. If it is certain, if something is certain, then P will be equal to 1. If it is impossible, P will be 0. Okay. So we don't, we are saying which is neither certain nor impossible. So D is the correct answer. The important characteristic of Bernoulli trial. See, that is why I have taken it exclusively, because you can get a question on that. Important characteristic of Bernoulli trial is each trial is associated with 2 possible outcomes, right? This is true. Yes. But don't be in a hurry just reading the first option. You say, yes, I know this answer. You are marking it, because you must read all the options in statistics, especially for the theory. Second is trials are independent. Is this true? Yes, this is also true. Trials are infinite. Is this true? Okay, what have we done here? The number of trials is finite positive integers. Okay, so this is not true. Okay, so what is true? A and B are true. So D will be the correct answer here. So just be careful. Okay, sometimes you know the answer, but because you did not read further, you mark an incorrect answer. So read, especially in statistics theory, read all the options and then mark. Okay, so till now we have talked about binomial distribution to be applied to experiments where there are only 2 outcomes, success and failures. The trials are independent. There is a finite number of trials, and then we use this. Okay, so now we are going to do going to the actual formula, how to calculate. So right now we have studied when we are going to apply a binomial probability distribution. So a discrete random variable x is defined to follow a binomial distribution with parameters. This is very important. Sometimes they may even ask you, what are the parameters of binomial distribution? What are they? N and P. Okay, they may show it like this. They may just write down N, comma P. Okay, all this means the same. A discrete, okay, so this is important because in the theoretical distribution, what is binomial distribution? It's a discrete distribution. X is defined to follow a binomial distribution with parameters N and P to be denoted by this. Okay, this is one of the ways to denote it. X is represented by B, N of P, N comma P, if the probability mass function of X. Okay, probability mass function of X is given by, this is the formula. Okay, Fx is equal to P, X is capital X is equal to small x, NCx, P raised to Q, Q raised to N minus X for X is equal to 0, 1, 2, 3 up to N. Because it's finite trial, so N is there. Okay, or 0 is 0 otherwise. So this is the value of the probability mass function. So let us see quickly, just when we have taken the formula, I'm taking the question. The probability mass function of binomial distribution is given by. Now, can you tell me? See, here, remember it is NCX. Okay, so there is a combination, permutation combination, you remember? So, NCX is there. So, in the first, do you have NCX? This is not there. So, this is automatically we are deleting. Now, amongst B, C, and D, which do you think is the answer? Quickly. Ninth question. Yes, Lakshita. Formula is just like permutation and combination chapter. So, Gia is saying C. Bhumika is saying B. Yes, Avinash will use combination also. Sakshi is saying B. Okay. So here you have to be careful because the formula is NCX, P raised to X, Q raised to N minus X. Okay. Here I've shown you NCX, P is raised to X. Okay. Bhumika, pay attention. P is raised to X. So here in C, Q is raised to X. So this is not true. Okay. Now between B and D, P is raised to X. Okay. So D is also not true. So B is the correct answer. Okay. Just be careful with the formula. Fx is equal to NCX, P raised to X, Q raised to N minus X. If X is a binomial variable with parameters N and P. Okay. Here I've already written. Okay. Parameters of binomial distribution is N and P. N is the number of trials. P is the probability of success. So if X is a binomial variable with parameters N and P, then X can assume any value between 0 and N, any value between 0 and N in both inclusive, any whole number between 0 and N, both is exclusive. So between B and C, what is the difference? The word whole number is there. And any number between 0 and infinity. Okay. So can you tell me the answer? For the 10th one. So Danshu, that's just the name. Okay. 10C. Yes, Sonali. Any whole number between 0 and N inclusive. Okay. Why we are saying whole? Because see here in the theory we have studied the number of trials is a finite, positive, and very important word, integer. Very important word is the integer. Okay. So here for 10th, what is the answer? It is C is the correct answer because 0 and N both inclusive. Can it be infinity? No, because the trials are finite. Okay. So this condition is not met. So this is gone. Any value between 0 and N, this is correct, but the word whole is not there. So both inclusive is C. This is correct, but this is B is more correct, but C is much more correct. So that is why C is the correct answer. Okay. So that is why I'm keeping on telling you this. Please read all the options before you put the tick mark. Okay. So Fx for binomial distribution, Fx is equal to NCX, where N is the total number of trials, P, which is the probability of success raised to X, and Q, which is the probability of failure raised to N minus X. Okay, and X takes the value from 0, 1, 2 up to N. Okay, NCX, where N is the total number of trials. Okay, and X is 0 to N, which is an integer. P is the probability of success, and Q is the probability of failure. Okay. Yes. So once you've understood the logic behind the formula also, it becomes easier. So that even if you make a mistake, when you get an answer, you suddenly you realize, oh, this can't be the answer. Okay. Why? Suppose you are asked to calculate P, but you know that P is always less than or equal to 1. So if I get P as equal to 2.5, that means I've made some mistake. So I must recheck my calculations. Okay. So important theory question. Apart from those, we have all these theory questions also. Now you know that n is greater than 0 because it is a finite number. P and Q are greater than or equal to 0. It follows that for that fx is greater than or equal to 0. Okay, because n is greater than 0, P and Q are greater than or equal to 0. So fx is also greater than or equal to 0 for every x. Also summation, this is very important, that that's what I was talking about. Summation fx, which is equal to f0 then f1 plus f2. Okay, the whole thing goes to up to how much? Fn. When I add this will also always come to 1. Okay, this probability will total to 1. Okay. Second, binomial distribution is also known as biparametric. Parameters are what are defining your distribution. To define a binomial distribution, we require two parameters. So which are those? N and P. N is the number of trials and P is the probability of success. So when I have that, bi means what? Bi means 2. Okay. Bi means 2. So biparametric means 2 parameters. So that is why we say that binomial distribution is a biparametric distribution. So that to define it, we require 2 parameters. As it is characterized by 2 parameters, which are those? N and P. This means if the values of N and P are known, we can understand the distribution completely. The mean is given by, so as we were talking, we can define mean, median, mode. So here mean is equal to mean of the binomial distribution is equal to what? N into P. Okay. So what is the first point, theory point? That N is greater than 0, PQ are greater than or equal to 0. This means that f of x is greater than or equal to 0. In that, the most important point is when I add all these f's. So f of 0, f of 1, f of 2 up to f of n, all these total should come to 1. That is the first important point. Second important point is that the binomial distribution is a biparametric distribution, means what? It is defined by 2 parameters. Bi means 2. Which are those 2 parameters? One is n and one is p. What is n? N is the number of trials. What is p? P is the probability of success. Then we have the third important theory question. What is the mean of a binomial distribution? Mean is given by n into p. Now fourth, depending on the values of 2 parameters, binomial distribution may be unimodal or bimodal. Okay, so now we are talking about the mode. Okay, the mode of binomial distribution. So it can be unimodal or bimodal. Okay. Now this is, you have to remember this, that I must first calculate n plus 1 into p. I must first calculate n plus 1 into p. There are 2 possibilities. Okay. Let me write it over here. I have a little space over here. So we are talking about mode of a binomial distribution. Mode of a binomial distribution. To find that, you should find n plus 1 into p. There are 2 possibilities. When I multiply this, either this is an integer or this is not an integer. Okay, that is, it is a fraction. If it is an integer, the modes are 2. If it is an integer, the modes are 2. So which are those two modes? First mode will be n plus 1 into p. Whatever you calculated, that will be one mode. Second will be n plus 1 into p minus 1. Okay. So there are two modes when n plus 1 into p is an integer. Which are those? N plus 1 into p, and the second is n plus 1 into p minus 1. What will happen when it is not an integer? Then what you do is you find the n plus 1 into p, find the largest integer present. Okay. Suppose I find out n plus 1 into p to be 2.5. Then 2 will be taken as the mode. What happens if I find 4.75? Then 4 will be the mode. We will discard the numbers after the decimal point. So this is typical for a binomial distribution, is that the mode of a binomial distribution, the binomial distribution may be unimodal or bimodal. When will it be unimodal? When n plus 1 into p is not an integer, then I take whatever the integer part is, that will be the mode of the binomial distribution. What happens when n plus 1 into p is an integer? Then I say n plus 1 into p will be one mode, and n plus 1 into p minus 1 will be the second mode. Okay. Have you understood till D? Then E. Then we find the variance. So here we found the mean. We now find the variance. So what is the variance of a binomial distribution? It is equal to NPQ. What does this mean is that standard deviation will be equal to square root of NPQ. Remember this? Because standard deviation is what? It is square root of variance. Okay. So the variance of a binomial distribution is given by sigma square, which is equal to NPQ. Okay. Now why know that mean is NP? I know that variance is NPQ. Sorry. Mean is NP and variance is NPQ. Now let us find out whether mean is bigger or variance is bigger. Okay. I have mean to be equal to NP. I have variance to be equal to NPQ. So is mean bigger or variance bigger? Let us find out. See, since P and Q are numerically less than 1, I know that it is a probability. So P is less than or equal to 1 and Q is also less than or equal to 1. So what happens is these numbers are always less than or equal to 1. So if I take this, then what happens? N into P into Q will be less than N into P. Okay. So variance of a binomial distribution is always less than its mean. So variance of a binomial distribution is less than mean of a binomial distribution. Okay. So this is an important part. And the second important thing here is, that variance is maximum. Variance is maximum when it is maximum at n upon 4. Okay. It gives the value at n upon 4. That is when P is equal to half and Q is also equal to half. If P is half, automatically Q will be half. I'm writing it over here. Okay. So here what we are talking about is that variance will attain a maximum value when P is half, Q is half, and at what point will you attain the maxima? If you will attain the maxima at n upon 4 situation. Okay. So I'll just revise this important theory. I know that n is greater than 0. I know that P and Q are greater than or equal to 0. Then we say that fx, the summation of fx will always be add up to 1. Okay. Second thing is that because there are two parameters which define the binomial distribution, one is n, that is the number of trials, and other is p, that is the probability of success, we say that binomial distribution is a biparametric distribution. Okay. Then third thing is that the mean of a binomial distribution is given by n into p. And then variance is given by NPQ, or standard deviation is given by square root of NPQ. Then we are talking about the mode of the binomial distribution. The mode of the binomial distribution has can be found out with the help of n plus 1 into p. Now, if this n plus 1 into p is an integer, then there are two modes for the binomial distribution. The one mode will be n plus 1 into p. The second mode will be n plus 1 into p minus 1. When this n plus 1 into p is not an integer, then I take only the largest integer that is there in that n plus 1 into p, and that will be my mode. Then going further, I say that variance is always less than the mean for a binomial distribution. Okay. Variance will obtain its maximum when p is equal to half, q is equal to half, and the point where we will obtain the maxima is n by 4. Okay, so I've taken the question, an example of a biparametric. Okay, so they have not asked you whether binomial is a biparametric. So here they are asking you the other way around. Which of the following is a biparametric distribution? Okay, we will be doing about the normal and the Poisson, where you will know that binomial is an example of biparametric discrete probability distribution. So it's biparametric also, and the word discrete is also important. So when it is biparametric and discrete, then the distribution will be a binomial distribution. The second is the biparametric distribution is never symmetrical, never positively skewed, never negatively skewed, and symmetrical when p is equal to 5. Okay, I will explain this also in a minute. I hope you were understood till now. Avinash, X will be given to you. Yes, Bhumika, understood. Jeba understood. Okay, great. Little, see this video 1 or 2 times, you will understand it completely. Theory point 1. Sagar, where did you see 16.1? That must be page number or something. Okay, yes. Yes, very good. Rohini? Yes. Yes, Bhargavi understood. Yes, good. Avdesh? Yes, very good. Sonali? Sonali, this is the answer to which question? Yes, Bibu, crystal clear. Bhargavi also. Sagar, okay. Yes. Now, when do we say yes? Now, what happens is that we plot here on the y-axis, we plot the probability. On the x-axis, we are plotting the number of trials, that is x. Okay. Now, what happens when my p is small? The probability will be like this, and when my p is large, The more the trial, the more the success. Okay. So, but when P is 0.5, what happens is I get symmetric. Okay. So this is the case when P is 5. Okay. So here what happens that when it is negatively skewed and when it is positively skewed depend upon the value of P. When P is small and when P is large. Okay. And what is this condition? The third condition is P is 0.5. Okay. Here and at this position, what will happen? Mean is going to coincide with mode. Mean is going to coincide with mode at this point. Okay. So negatively skewed, or the other word for negatively skewed is left skewed, and positively the words are right skewed. Okay. So this is why we have this symmetrical at 0.5. I have shown you that also. The mean of a binomial distribution is always more than its variance, always equal to its variance, always less than its variance, always equal to its standard deviation. The mean here. So what is the point saying? Variance of the is always less than the mean. So that means mean is always, the word always is given here. Here they are saying variance is always less than the mean. So what does this statement imply? Mean is always greater than variance. So we will write mean is always more than the variance. Okay, 16 is B. Mean of a binomial distribution is given by NPQ, NP both or none. It is given by N into P. So we are saying mu is equal to N into P. The mean of a binomial distribution with parameters N and P is given by. So same question, but how they have written here, instead of writing Q, they are using only P. What is the difference between the 8th and the 12th? So here in mean of binomial distribution, they have used P in the options. Here they have used 1 minus P in the option. So you don't have to get confused, but because you already know that mu is equal to N into P. So C will be the correct option. Okay. The variance of a binomial distribution with parameters N and P is given by, what do you know? Variance is equal to NPQ. So I can write this as NP. Instead of Q, what can I write? 1 minus P. Okay. We know that Q is equal to 1 minus P. So I can write it like this. Okay. So either you get the question in this format or you can get it in this format. So in this case, the variance of a binomial distribution with parameters N and P is given by, is it NP square 1 minus P, NP 1 minus P, okay, NQ 1 minus Q, N square P square 1 minus P square. Now tell me which of this, okay. Now here they have even tricked you again, okay. So variance I know is NPQ. Here in this, I have written Q in terms of P. Here I am going to write down P in terms of Q. So P is what? P is equal to 1 minus Q. So NPQ can be written as N 1 minus Q into Q. So this can be written as NQ 1 minus Q. Okay. So do I have a square root? Square? No. So this is not the correct answer. Is this correct? This is the formula for standard deviation. This is not the formula for variance. This is the formula for standard deviation. So this option is also not correct. Now, N square P square 1 minus P square, this is not correct. So this is the correct option. Why here the formula for variance is written in terms of Q. This is the formula for variance in terms of P and Q. This is the formula for variance in terms of P. And this is the formula for variance in terms of Q. Okay. So you have variance to be equal to NPQ or it is equal to NP1 minus P, or it is equal to NQ1 minus Q. Okay, so you can take this down that these are the three formula for variance. Okay, you need to remember only one of them. Once you know one of them, you can always substitute, because all you need to remember is that P is equal to 1 minus Q and Q is equal to 1 minus Q. Just check whether you've understood it now. Yes, Shivangi, crystal clear. Yes. Abhinav, this is a very good chapter. Yes. Yes, N into P, Sakshi, correct. Rohini, understood. Lakshita, you can use any one when you are solving the problem, but when this is when options are given, you have to choose from given options. Okay, so that time you won't have a choice. So here in this, you will see if the answer is given in terms of Q, you will write it in terms, you will tick mark the one in Q. If the answer is given in terms of P, you can do that. Okay. Yes, Bhargavi, clear. Divya, Avdesh, yes, understood. Okay. Very good. Himanshu is understood. Yes, Shivangi. Very good. Okay. Now, for a binomial distribution, mean and mode, they are asking whether the mean and mode are never equal, always equal, are equal when Q is equal to 0.5, do not always exist. So, I showed you on the graph over here. Okay. When this is the case, okay, when this is the case, where will be your mode? Okay. Here, let me use a different color. At this point, this will be your mode. Okay. Mode is what? Where you have the highest frequency, right? And where will your mean be? Somewhere here. This will be your mean. Okay. So, this is not correct. When you have a positively skewed or right skewed, this is mode will be less than the mean. When you have the negatively skewed, here will be your mode, and somewhere here will be your mean. So mean will be less than the mode. Here, this is when P is equal to 0.5 and Q is equal to 0.5, mean will be equal to mode. Okay. So this concept, the question they've asked here is, for a binomial distribution, when will they be equal? The condition is that when Q is equal to 0.5. Okay. The mean of a binomial distribution is always more than its variance, always less than its variance, always equal to its variance, always equal to its standard deviation. What do we know? That mean is always greater than variance for a binomial distribution. So mean of a binomial distribution is always more than its variance. For a binomial distribution, there may be one mode, two modes, multi-modes, A or B. Okay. See, for a binomial distribution, either you can have one mode or two modes. Can you have multi-modes? No. One or two. So, B will be the correct answer. The maximum value of variance for a binomial distribution with parameters N and P is, okay. So 18th question, we have to go back to this, okay. This is important. I've already marked a star over here, right? Also, variance of X attains its maximum value when variance is maximum when at n by 4. When will that happen? When P is half and Q is half. Okay. So that is answering your 18th question. that maximum value of variance for a binomial distributed parameters n and p is n by 4. Here they should have also mentioned that p is half. Okay, but this is the maximum value that you can attain for a variance. Okay, so we are saying that mean is given by n into p, variance is given by npq, standard deviation is also represented by S is given by NP, square root of NPQ. Remember, mean is always greater than variance. Okay. Variance has a maxima at n upon 4. Then at P is equal to half or Q is equal to half, we have mean to be equal to mode. Okay. Also remember that binomial distribution can have one or two modes. Okay. Also remember binomial distribution is a biparametric. Also that it is given by fx is equal to f0 plus f1 plus f2 plus so on up to f of n. This summation is going to add up to 1. Always remember p plus q is 1. P is equal to 1 minus q or q is equal to 1 minus p depending on what is required of you. Then the main important formula for doing sums is f of x is equal to ncx p raised to x q raised to n minus x, where p is the probability of success, q is the probability of failure. Okay, and what is ncx? It is simply the combination. So okay, so here I have written the formula again, ncx p raised to x q raised to n minus x. Okay, here, and n is going from 0 1 2 up to where? Up to x is going from 0 1 2 up to n, where x is going from. Okay, so I have summarized this. Okay, so we go to the first question, that is set P 6.43. If x is a binomial variate with parameters 15 and 1 by 3, what is the value of mode of the distribution? Okay, so what is n? N is equal to 15. What is p? P is equal to 1 by 3. Now to find out mode, what do? I need to find out n plus 1 into p. Then once I found out if this is an integer, then there will be two modes. First mode will be equal to n plus 1 into p. Second mode will be equal to n plus 1 into p minus 1. If this is not an integer, then mode will be equal to the highest integer in n plus 1 into p. Okay, so this is how we define. So let me find out. So let me find out n plus 1 into p. This is equal to, what is the value of n? 15 plus 1. What is the value of p? 1 by 3. So this is equal to 16 upon 3. What is the value of 16 upon 3? 16 divided by 3 is how much? 5.33. Okay. So what should we consider? We should only consider this. Okay. So in this question, mode is equal to 5. Okay. So B will be the correct answer. Just take your time, go through the answer and understand it. Okay. Yes, Lakshita. Yes. Madiha. Yes, you've understood correctly. Yes. Excellent. Excellent. Now let us go to the 16 on page 16.10. There is this example 16.9. So again, we will try to find the mode so that you will be able to understand this clearly. Yes, Sudhanshu, I'm already taking another question of same type. Okay. What is the mode of the distribution for which mean and standard deviations are given as 10 and root 5 respectively? Okay. Now mean is equal to n into p is given as 10. Standard deviation, which is equal to sigma, which is equal to square root of n p q is given as root 5. Okay, this is the information that is given to you. Now, I don't want like this square root, so I say squaring both sides. What do I get? N P Q is equal to 5. Squaring both sides, I'll get N P Q is equal to 5. Now I know mean NP is equal to 10. So instead of this NP, I will write 10Q is equal to 5. Okay. I have mean which is equal to NP is equal to 10. I have been given standard deviation is equal to square root of NPQ is equal to 5. So this equation for standard deviation, I square it. So I get NPQ is equal to 5. So instead of writing NP, I write 10. And so I get Q is equal to 5. Q is equal to 5 by 10, which is equal to half. Okay. So if Q is equal to 5 by 10, what is the formula for P? P is equal to 1 minus Q. So this is 1 minus half. So P is equal to half. Okay. 1 minus half is equal to half. Half can also be written as which is also equal to 0.5. Write down in whichever way is comfortable to you. If you are comfortable with decimals, write it in decimals. If you're comfortable with fractions, write it in fractions. Okay. So what is the mode of the distribution for which now I have got the value of P. Now for calculating mode, what do I need? What is information? N plus 1 into P. Now P I have got, but I still not got N. So what do? I write down mean is equal to N into P. Mean I know is 10. N I don't know. P I know is 0.5. So N will be equal to 10 upon 0.5. What is 10 upon 0.5? It is equal to 20. Okay. 10 divided by 0.5 is equal to 20. Now okay. So now I have N. So N is equal to 20 and P is equal to 0.5. Let me now try to find out n plus 1 into P, which is equal to 20 plus 1 into 0.5. How much will this be? 21 into 0.5? 21 into 0.5 is 10.5. Now, is 10.5 an integer? Answer is no. Since 10.5 is not an integer, so I have mod to be equal to 10. I ignore the 0.5, so I have mod equal to 10. Is that clear now? Okay. So, first example, I have also done for mode, and this is the second example I have done for mode. Excellent, Vanshika. Yes, Aspreet. Yes. Very good. Very good. Okay. There are two ways to it. The moment you got P as 0.5 and Q as 0.5. Yes, Aspreet. I know the condition in binomial distribution when mean is equal to mode is when P is equal to 0.5. Here itself I came to know that, so I can directly, without even doing all this, I can directly write down mean is equal to mode. So mode is equal to 10. Excellent. If you remember those properties, you are saving such a lot of time, right? Yes, Esprit. Good, very good. Yes, Harnoor, we are taking a break. Sudhanshu, you're not paying attention. What have I told you here? If n plus 1 into p is an integer, you know what an integer is, right? Okay, when there are no fractions, you say the number is an integer. So when it is an integer, you will have these two modes. When it is not an integer, I will only take the number which is before the decimal point. Okay, understood, Sudhanshu? Yes, Bhargavi, only when there is not an integer. Suppose n plus 1 into p comes out to be 5. Okay, suppose, I shouldn't write it here. Now suppose I get n plus 1 into p to be 5. Then the mode will be 5 and 5 minus 1, which is equal to 4. Okay, so the two modes will be 5 and 4. Yes, Bibu. Yes. Mean will be equal to mode when p is equal to half. Okay. Understood, Bhargavi? Sudhanshu, have you understood now? Yes. Nitin? Yeah. Avinash, you have got it. Excellent, excellent. Yes. So let us take a break for 5 minutes and then we come back and we'll do more sums on binomial distribution. Yes. Welcome back. Okay. Yes, thank you, Bhargavi. You find the class very interesting. That's so great to know. And Bibhu, concepts are getting crystal clear. Excellent. So here now, just let me quickly revise. It's already written over here that for a binomial distribution, mean is given by n into p, variance is given by npq, standard deviation is given by square root of npq. Mean of a binomial distribution is always greater than its variance. Variance will have a maxima at n by 4 when p is equal to 1/2. Okay, and at that, when p is equal to 1/2, you will have mean will be equal to mode. Then binomial distribution is a biparametric distribution and it can have one or two modes. How do I find out whether the distribution has one mode or two modes? When I find out n plus 1 into p, if that is an integer, then we have two modes. One mode will be n plus 1 into p and the other will be n plus 1 into p minus 1. And when this is not an integer, that is n plus 1 into p is not an integer, then I will only take the highest integer in this factor n plus 1 into p, that is the number before the decimal point, that I will be taking as my mode. Also remember that summation of fx, that is f0, f1, f2 up to fn is equal to 1. Then n plus p is always equal to n plus q, not n, p plus q is always equal to 1. P is defined by 1 minus q, that is it is the probability of success. Q, that is the probability of failure, is 1 minus p. Then the formula that we'll be using for doing the sums now is fx is equal to ncx, p raised to x, q raised to n minus x, where x goes from 0 to n. And that is the number of trials are finite and it is integers. Okay. So there is another property. Yes, this is also a good property, that is that when you have two independent variables x and y, such that for x variable I have a binomial distribution, for y I have another binomial distribution. For both the probability p, or probability of success p, is equal. Okay, so if I have that, but for x, the number of variables, the number of trials is n1. For y, it is n2. Okay, so I have two distributions, x and y. And for the first distribution, the probability of success is p. For y, also the probability of success is p, but the number of trials are different. That is, for x it is n1, then for y it is n2. Then I can combine this. Then I can combine these two distributions and say that x plus y will have a binomial distribution. Then if I add these two binomial distribution, the resultant will also be a binomial distribution with number of trials to be equal to n1 plus n2, and probability will be same, that is p. Okay. Again, I repeat, there are two independent variables x and y. For x, the binomial distribution is n1p. For y, the binomial distribution is n2p. When I add these two binomial distributions, so then then it will be a binomial distribution with variables n1 plus n2 and p. Okay. So let us quickly take an example on that. If x and y are two independent binomial variables with parameters 6.5 and 4.5 respectively, what is p of x plus y greater than or equal to 1? Okay. So for x, what do we have? We have the binomial distribution 6.5. For y, I have the binomial distribution 4.5. Okay. Now, what is the this p of x plus y greater than or equal to 1? So I can see here this is half, so I can use the additive property. So p is same. I can use the additive property. Okay. So let Z be equal to X plus Y. If I'm saying let Z be equal to X plus Y, what is the question becoming? Then P of X plus Y greater than or equal to 1 will be equal to P of Z greater than or equal to 1. Then you have P Z greater than or equal to 1. Now Z may be 1, 2, 3, 4, 5, 6. I don't know, right? This total can come to I don't know how much. So what is the way you do it when such questions come? When I have to find more and more, so why do this as write this as 1 minus P of Z less than 1. Something is greater than 1, 2, 3, 4, then I will write this, that probability of finding Z greater than 1 is equal to probability of finding 1 minus P Z less than 1. Because I know these two probabilities added together should give me 1. Okay, these two probabilities added together should give me 1. So P of Z greater than or equal to 1 is equal to 1 minus P of Z less than 1. Now, what is P Z less than 1? This is nothing but 1 minus P Z equal to 0. Okay, this is P Z is equal to 0. Why? Because Z cannot be negative and it is an integer. So what will happen? This will Z, we just have to find 1. Otherwise, I would have to find out many, but now I know that I just have to find a Pz equal to 0 from 1. When I subtract this situation, what will I get? I will get the probability for Z greater than or equal to 1. Okay, here we have written this. Okay, f of x is equal to f1, f2, f3, f up to xn. So if I take out this, okay, so what do I have? I have 1 is equal to f0 plus f1 plus f2 plus so on plus fn. Okay. Now what happens is, if I want to find out when Z is greater than or equal to 1. So what do they want? They want this. They want this. They are asking you to find out this much. Z is greater than or equal to 1. So instead of finding all this, because this will increase my calculation. So for this, what do I write? I write this as f of 1 plus f of 2 plus so on up to f of n. I can write this as 1 minus f of 0. Okay. This f of 0, I take it over here. So I can write it as 1 minus f of 0. That is what we are doing over in this question. Okay. Same thing. You already know that property. So here I am doing 1 minus p z of 0. Okay. Now what is the value of n? Okay. I use the property, then that n will be equal to 6 plus 4, which is equal to 10. What is the value of p? P is equal to half, right? This is the property I am using. Okay. Then for x plus y, this is b of n1 plus n2 and p. So this binomial distribution, when I combine the binomial distribution of x and that of y, I get another binomial distribution for z, which has the parameters 6 plus 4, that is 10, n is equal to 10 and p is equal to half. So what will my pz be? What will be my probability distribution be? This will be equal to 10c x. P is half, so Q is what? Q is also half. P is half raised to x and half raised to 10 minus x. Okay. So, given this question, I will form this probability distribution. How will the probability distribution be defined? It will be defined by 10cx p which is equal to half raised to x, and again q, that is half raised to 10 minus x. Okay, now what do I want? I want at x is equal to 0. So, okay, so this will be equal to p or z is equal to 0 will be equal to 10c0. Don't confuse this x with this x. Okay, so this is 10c0, 1/2 raised to 0 into 1/2 raised to 10 minus 0. So p z is equal to 0 is equal to 10c0 will be how much? 10 factorial upon 0 factorial into 10 minus 0 factorial, which is again 10 factorial. Half raised to 0 is how much? 1. So any number raised to 0. Remember in indices we have done a raised to 0 is 1. So I'm using this. Don't write 0 over here. Half raised to 0 is 1. And half raised to 10 minus 0 is 10. So 1/2 raised to 10. So this is 10 factorial upon 10 factorial getting 1. So this is equal to 1 upon 2 raised to 10. 2 raised to 10 is equal to 1024. You can do it on the calculator, but it is better you learn this. Otherwise, every time you have to spend doing that. So this is 1024. Okay. P of z is equal to 1 upon 1024. Now, what do I want to find out? I want to find out P of z greater than or equal to 1. What is the formula? 1 minus P z equal to 0, which is equal to 1 minus. What is P z equal to 0? I found out as 1 upon 1024. So, what will this be? Taking the LCM 1024. So this will be 1024 minus 1. So P z greater than or equal to 1 will be equal to 1023 upon 1024. This will be the answer for this question. If x and y are independent binomial variables with parameters 6 and 1/2 and 4 and 1/2, what is p x plus y greater than or equal to 1? This probability value is equal to 1023 upon 1024. Okay. Yes, Lakshita, I will explain again. Don't worry. Yes, Zeba. Zeba, you will have to see whether they are showing it in decimal or they are showing it as a fraction. So, yes, 0 factorial is 1. Forgotten permutations? Harnoor? Yes, Agar, I am explaining again. So what is the property that if I have a binomial distribution, one binomial distribution with n1p, and I have another binomial distribution with n2p as the parameters, then if I add these two binomial distributions, if I add them, then I will again have a binomial distribution with parameters n1 plus n2 and p. Okay. Then I will have n1 plus n2 and p. So right now what do I have? I have a binomial distribution with 6.5. Okay, 6 is the number of trials, 1/2 is the probability of success. I have another binomial distribution with 4.5. That is 4 is the number of trials and 1/2 is the probability of success. Then when I want to add these two binomial distribution, what binomial distribution will I get? 6 plus 4.5. So this new binomial distribution, I will have 10.5. Okay. Now, for this binomial distribution, for this new binomial distribution, I have 10.5. Now, what do I want? I want the situation where I want to find the probability, not F B, but I want to find the probability when the Z, when X plus Y, okay, when X plus Y is greater than or equal to Y. This is for my X, this is my X, and this is my Y. Or instead of writing X plus Y greater than, I put Z is greater than or equal to 1. Here I have a binomial distribution 10 and half. Okay. So binomial distribution, what do I have? I already have. I combined these two. I've got 10 and half. What will be the fx? Okay. What will be the fx? What is the formula for fx of a binomial distribution? NC. Okay. Let me write down this as R. Okay. Let me write it as f of r. So this will be NCR p raised to r q raised to n minus r. Just so that there is no confusion between the x that is given and this. So FR, this is the formula for binomial distribution probability. So f of r is equal to NCR p raised to r q raised to n minus r. So for this, what is the value of n? N is 10. What is the value of p? P is half. What will be the value of q? Q will also be half. N is 10, p is half, q which is equal to 1 minus p, which is equal to 1 minus half, which is equal to half. Okay. I have these values. Can I substitute? Yes. So p of f of r is equal to 10 CR half raised to r and 1 half raised to 1 minus r. 10 minus r is equal to this will be equal to 10 minus r. Now what do I want to find? I want to find the probability for the situation. I want to find out then x plus y is greater than or equal to 1. So that for this is nothing but 1 minus f of x plus y, that is z, is equal to 0. Okay. Or this r is equal to 0. So how do I do that? I just substitute here. I put r is equal to 0. So I get this is equal to 1 f of 0. Let me put this f of 0 to be equal to 10 C0 1 half raised to 0 and 1 half raised to 10 minus 0. When I solve this I get as 1 upon 1024. Okay, solution you can see earlier also. I get this. So here I substitute this is equal to 1 minus 1 upon 1024. This I am substituting over here. And when I solve this is equal to 1023 upon 1024. Okay. I will suggest that you see this video 1 or 2 times more, so you will be understanding it. So I have covered this sum properly. Okay. Let us go to the next sum, that is 16.1st sum. So even though this question has 3 sub questions, you will get only one of them. Okay. You will not get in one question for 1 mark all 3. Okay. So just do them very easily. Just concentrate on whatever is asked. So they may ask you this type of questions. A coin is tossed 10 times. Assuming the coin to be unbiased, what is the probability of getting 4 heads? At least 4 heads, at most 3 heads. So when I'm talking of 4 heads, what I'm saying is that value of x is how much? X is 4. At least 4 heads means what? X can be how much? 4, 5, 6, 7, 8, 9, 10. Now 1, 2, 3, 4, 5, 6, 7. 7 times I have to calculate. Okay, this probability function NC0 P raised to NCR P raised to R Q raised to N minus R, or NCX P raised to X Q raised to N minus X. So 7 times. So instead of that, what do I do is I calculate this for 1 minus 0, 1, 2, 3. Okay, 1 minus 0, 1, 2, 3. So how many times do I have to calculate? I have to calculate for x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3. Only that much. At most 3 heads. Once I calculate this, at most 3 heads is this. Okay. So understand the question. Now a coin is tossed 10 times. What is this 10? This gives n is equal to 10. Now when I'm saying coin, what does this imply? That I can get either a heads or a tail. Okay. That means I can apply binomial theorem here. Okay. I can use binomial distribution here because I have heads and tails. There are only 2 outcomes. So if I say heads is a success, what is the probability of head? Half. What is the probability of getting a tail? Half. Okay. So I know I've got my P, I've got my N. And so for a binomial distribution, I need only 2 parameters, P and N. I've got both. So here, this will be equal to how much? So my fx, what is my N? 10. C, x. P is how much? Half raised to x. And Q is also half raised to, half raised to 10 minus x. Okay. This is the probability mass function for x for when you toss a coin 10 times. Okay. Now here. Now let us go to the first part. So I will just write it here. F of x is equal to 10cx half raised to x and half raised to 10 minus x. Now first question is 4 heads. Okay. So what do I have to find? For x is equal to 4. Okay. 4 heads. So this will be equal to 10c4 1 half raised to 4 and 1 half raised to 10 minus 4, which is equal to 6. Now 1 half raised to 4 and 1 half raised to 6, which will be 1 half raised to 10. So 10c4, can you find out? 10 factorial upon 4 factorial into 6 factorial. This is equal to 1 half raised to 10. Now what is 1 half raised to 10? It is 1 upon 1024. Now what will this solution be? 10 into 9 into 8 into 7 upon 2. 4 factorial is 24 and this is equal to 1 upon 1024. So 8 ones are 8 threes are 3 ones are 3 threes are. So this is equal to 210 upon 1024. You can simplify it further or let it be as it is depending on what your options are. So f of x is equal to 4. You have this. Second is at least 4 heads, which I am saying you have to find for 4, 5, 6, 7, 8, 9, 10. Instead of that, I am going to find it for 1 minus 0, 1, 2, 3. Because once I have done this, I will be able to find out, I will be needing less time. Okay. And where do I get this? This is because f of x is equal to f of 0 plus f of 1 plus f of 2 and so on up to fn, which is equal to 1. So using this property, I'm going to find out at least 4. So at least 4. So I have f x is greater than or equal to 4, which is equal to 1 minus into bracket. Remember to put the big bracket, f of 0 plus f of 1 plus f of 2 plus f of 3. Okay. Now what is 0 and 2? That is the value of x. Okay. So let me find out f of 0. F of 0 will be equal to 10c0 half raised to 0 and half raised to 10 minus 0. Okay. This we have already just calculated. 10c0 is 1. Half raised to 0 is 1. And 1 half raised to 10 is 1 upon 1024. Now let us find out f of 1. This is equal to 10c1, 1 half raised to 1 and 1 half raised to 10 minus 1. So how much will this be? It is again going to be 1 upon 1024. Now 10c1 will be equal to 10 factorial upon 1 factorial into 10 minus 1, that is 9 factorial into 1 upon 1024. Now 10 factorial upon 9 factorial is 10. So this is equal to 10 upon 1024. Okay. Again I find out f of 2. F of 2 which is equal to 10c2 1 half raised to 2. Again 1 half raised to 10 minus 2 which is equal to 8. This is equal to 10 factorial upon 2 factorial upon 8 factorial, and this is equal to 1 upon 1024. So this becomes 10 into 9 upon 2 into 1 upon 1024. So 2 ones are 2 fives are. So I get f of 2 as 45 upon 1024. Okay. Now I can find out f of 3. F of 3 to be equal to 10c3 1 half raised to 3 and again 1 half raised to 10 minus 3 which is equal to 7. So this is equal to how much? 10 factorial upon 3 factorial into 7 factorial, and 1 half into raised to 3 and 1 half raised to 7. 3 plus 7 is 10. So this is again 1 half raised to 10 which is equal to 1 upon 1024. Because this number inside is same, only when this is half, you can do this quickly. Otherwise, you have 1/3 and 2/3. You have to again calculate for 1/3 differently and for 2/3 separately. Now, this is equal to how much? 10 into 9 into 8. How much is 3 factorial? 3 factorial is 6 into 1 upon 1024. So, 3 2s are, and this is 4. So this is 120 upon 1024. Now I have got the value of f3, I have got the value of f2, I have got the value of f1, and I have got the value of f0. So I will write this as f for x greater than or equal to 4. This is equal to 1 minus for f0. How much do I have f0? 1 upon 1024. F0, I have 1 upon 1024. F1, how much do I have? 10 upon 1024. Then F2, I have 45 upon 1024. And for F3, 10, 9, 8. Okay, yes, 120. So this is 120 upon 1024. Okay. So how much will this be? Yes. So this is equal to 1 minus, denominator is how much? 1024. This is 1 plus 10 plus 45 plus 120. Let me check. So this is how much? 1 plus 45 plus 10 plus 120, 176. Okay. So this is equal to 1 minus 176 upon 1024. How much is this? That is equal to 1024 minus 176 upon 1024. Minus 1024, which is equal to 848 upon 1024 divided by 1024, which is equal to 0.8281 is the probability that you will get x greater than or equal to 4. That is, you will get 4 heads when you toss the coin for 4 or more heads when you toss the coin 10 times. Okay. So when the coin is tossed for 10 times, the probability of getting 4 heads, 4 or more heads is 0.8281. Okay. The third part of the question is at most 3 heads. Okay. At most 3 heads. At most 3 heads means what? Means no head plus 1 head plus 2 head plus 3 head. Okay. This is the meaning of the English phrase at most 3 heads. So that is, when I'm tossing the coin 10 times, I'm not getting a head. I'm getting 1 head, 2 head or 3 head. So what happens here is f of at most 3 heads will be equal to f of 0 plus f of 1 plus f of 2 plus f of 3. Okay. So for that, what is f of 0? I just found out this is equal to 1 upon 1024 plus f of 1. What is the value of f of 1? 10 upon 1024 plus 10 upon 1024. What is the value of f2? f2 is 45 upon 1024 plus 45 upon 1024 and f of 3 is 120 upon 1024. Again, I have the common denominator 1024, 1 plus 10 plus 45 plus 120. How much is this? 120 plus 145, 165, 166 and 10, 176 upon 1024 will be the probability of getting at most 3 heads when I flip a coin 10 times. Okay. Yes. This is a big question, but you don't worry, you will get only one of these if you get them. Most of the questions when you are defined with n and p, you'll be asked to find mean, you will be asked to find variance, you will be asked to find a standard deviation. You will get all those theory questions, but this is very important for you to understand. Many of you may even go for financial engineering. So at that time, all this thing that you have done, all the hard work you've done in your foundation is going to pay you off in a big way. Okay, so understand this properly. Okay, try to understand this. You will automatically get the answers. Don't panic. Just don't be that I must get the answer, but you must understand the process. Okay, once you understand how the sum is handled, or what is the meaning of F0, F1, that is, when you say F1, what does it mean? It means that the probability of it getting the success one time is how much? Okay, so that once you've understood the concept, this becomes easy for you to understand. Okay. So can we move to the next question? Yes, Lakshita, perfectly understood. Great, great. Yes, Jyoti, you will have to solve it in the place provided and then you have to just take. Remember, there is negative marking, so just be careful. Yes, Vaishnav, very good, very good. Excellent. Sakshi, very good. Zeba, very good. Sonali, Vibhu. Yes, Nital. Okay. So depending what the options are, you may have to simplify it or you may have to keep it like that only or you may have to convert it into decimal. Okay. Let us go to 16.2. Now, if 15 dates are selected at random, what is the probability of getting 2 Sundays? Okay. There is 1 Sunday in a week. Right? So, we are getting a Sunday to be success. So, probability of getting a Sunday, I mark it as P. What will be the probability of getting a Sunday? 1 upon 7. Okay. In a week has 7 days. Okay. Now you know where the 7 is coming. P is equal to 1 by 7. 1 by 7 is the probability of getting a Sunday. Okay. Is the probability of getting a Sunday. Okay. Now 15 is there. So N is equal to 15. We are getting 2 Sundays. So I have X is equal to 2. P is equal to half 1 by 7. Q will be equal to 1 minus 1 by 7, which is equal to 6 by 7. Okay. So what will be my fx function? 15cx 1 half 1 upon 7, not 1 half, 1 upon 7 raised to x and 6 upon 7 raised to 15 minus x. Let me write this in a different color. What does the formula say? What is the formula for a binomial distribution? Fx is equal to ncx, p raised to x, q raised to n minus x. So f of x for this distribution, n is how much? 15. So 15cx, p is how much? 1 by 7 and q is how much? 6 by 7. 1 by 7 raised to x and 6 by 7 raised to 15 minus x. Okay. So this is your probability mass function. Now Okay, so whenever these questions for binomial distribution or Poisson or normal distribution, you have to first form the function and then you just have to substitute. The forming of the function is easy, but you have to do that step. Don't skip that step. Otherwise, what happens? You are directly trying to substitute and you may miss out on something. So, at least while practicing, you do this way. That you take the question, find out the value of n, find out the value of p, find out the value of q, substitute, form the equation, form the distribution and then substitute final answers. So now here what do they want? They want Sundays. How many Sundays do they want? They want 2. So that is the value of x. So because what have we defined as success? The definition of success is that I get a Sunday. Okay. So f of 2. Why am I not getting a good handwriting today? I don't know. F of 2 is equal to 15c2, 15cx. So 15c2, 1 upon 7 raised to 2, 6 upon 7 raised to 15 minus 2. Now let us see 15c2. Remember permutation and combination chapter, 15 factorial upon 2 factorial into 15 minus 2, that is 13 factorial. 1 upon 7 raised to 2 and 6 upon 7 raised to 13. Okay. Now 15 factorial, 13 factorial, they get cancelled. 15 into 14 upon 2 into 1 upon 7 raised to 2, 6 upon 7 raised to 13 gives you 6 raised to 13 and 7 raised to 15. That is 7 raised to 13 plus 7 raised to 2. So 7 raised to 15. Now this is 2 1s are, 2 7s are. So this is 105 into 6 raised to 13 upon 7 raised to 15. Okay. So this will be the answer. They may give you how much is the value of 6 raised to 13, 7 raised to 15, and you just have to substitute and find the answer. Okay. Or they may keep the answer in this format. Okay. For those of you who get confused or who did not pay to the attention to the chapter indices, I'm just explaining here. 1 upon 7 raised to 2 into 6 upon 7 raised to 13. What does this mean? This means I can write it as 1 raised to 2 this can be written as 1 raised to 2 upon 7 raised to 2 into 6 raised to 13 upon 7 raised to 13. Okay. Please pay attention. Those of you who don't remember. Now 1 raised to 2. 1 square is 1. So I don't have to write. 6 raised to 13. I write it as it is. Now in the denominator, I have the this a raised to m into a raised to n. Remember indices? A raised to m plus n. That I'm going to use over here. So 7 raised to 2 into 7 raised to 13 is equal to 6 raised to 13 upon 7 raised to 2 plus 13. So numerator there is no change, but 7 raised to 2 plus 13 is 7 raised to 15. So this is how. Sometimes you get confused. Where did this 15 come? Numerator there is 13, denominator there is 15. Ma'am, kahan se aaya? So aise aaya. Okay. So understand this. Remember. And if you don't remember, just revise your chapter on. First chapter is very, very important for you to get excellent marks in mathematics, because everything that is done in the first and second chapter, you are going to require everywhere. Okay. So I hope you've understood this, how we have got the answer. So the final answer for the given question is 105, 6 raised to 13 upon 7 raised to 15. Yes, Bhargavi, x is equal to 2. Yes, Sakshi. Once you do 6 raised to 13, find that value 7 raised to 15 and then you can do it. 15 into 7 is 105. Yes, Swati. Vibhu, Zeba. Yes. Divya, have you understood? Okay. So going to the next sum, 16.4. Just put in the chat box, all of you who have understood, please put them. Now going to the next sum, that is 16.4. Find the probability of a success for a binomial distribution satisfying the following relation. 4 p of x equal to 4 is equal to p x is equal to 2, having the parameters n as 6. Okay. So I have, for a binomial distribution, I need two parameters n and p. So n is 6. P I don't know yet. But what they have given me is p x is equal to 4 into 4 is equal to p x is equal to 2. Now what does my formula say? Let me write the formula in a different color. So what is the formula? F of x for a binomial distribution is ncx p raised to x into q raised to n minus x. Now I have got this as n is 6. Okay, but I need to know this. So for x is equal to 4, for f of 4 will be equal to 6c4 p raised to 4 and q raised to 6 minus 4, because my n is 6 and x is 4 here. Similarly, for x is x equal to 2, this is 6c2 p raised to 2 q raised to 6 minus 2. What is 6c4? 6 factorial. This is equal to 6 factorial upon 4 factorial into 2 factorial into p raised to 4 q raised to 2. Okay. 6 minus 4 is 2. How much is this? 6 factorial. This gets cancelled. 5 into 6 upon 2 p raised to 4 q raised to 2, which is equal to 6 1 2 ones are 2 3s are, this is 15 p raised to 4 q raised to 2. Similarly, this 6c2, 6c4 and 6c2 are complementary. So this will again be 15 p raised to 2 q raised to 4, 6 minus 4, that is 6 minus 2, that is 4. Okay. So I have got F4 and I have got F2. Now what are they saying? 4 into F4 is equal to F2. Now 4 into F4 is how much? 4 into 15 p raised to 4 q square is equal to 15 p square q raised to 4. Okay. So this 15 and this 15 will get cancelled. So what do I get? This is 4 p square is equal to q square. Okay. P square is equal to q square. So I have 4p square is equal to 1 minus p. Instead of q, I am writing this square. So 4p square is equal to 1 minus p square is 1 plus p square plus minus 2p. Okay. So this gives you 3p square. This p square I take to that side, it becomes 3p square minus 2 becomes plus 2p and this becomes minus 1 is equal to 0. So I take everything onto the left hand side. So I have got this quadratic equation. You can solve the quadratic equation. So what will you get? You will get 3p square plus 3p minus p minus 1 is equal to 0. So you get 3p, p plus 1 minus 1, p plus 1 equal to 0. So I get p is equal to 1 by 3 or minus 1. But I cannot have probability as minus 1. So what will be the probability? this will be the probability. So P is 1 by 3. So find the probability of a success for the binomial distribution satisfying the relation this. So what is the probability of success? 1 by 3. Okay. So just put in whatever information is given. N is given to you. P is not given to you, but they have given the values of X. So for that values of X, find out the two equations and then equate it given according to the equation that is given, that is 4P4 is equal to P2. So using that, I found out and I solved the quadratic equation and I found out P is equal to 1/3 or minus half, minus 1, but probability cannot be negative. So I get P is equal to 1 by. Understood this question? Yes, समझ में आ गया ज्योति? Very good. Bhumika, Sonali, Vibhu, Soumya, Zeba. Yeah. Find the binomial distribution for which mean and standard deviations are 6 and 2 respectively. Okay, here they are asking you to find the binomial distribution. So they would want you to find out if x is equal to ncx, p raised to x, q raised to n minus x. That they want you to find out. Now they have given you mean. Mean which is equal to value is how much? 6. 6 is equal to how much? N into p. Then they have given you standard deviation. That is sigma, which is equal to square root of npq. Now what is the value of this? 2 is equal to square root of npq. That they have given you. Now what you will do for this? Squaring both sides, I get 4 is equal to npq. 2 square is 4 and square root of npq, the square root sign goes npq. Instead of np, what can I write? 6. So 4 is equal to 6 into q. So q will be equal to how much? 4 upon 6. I simplify this. This is equal to 2 upon 3. So I've got the value of q. So p is how much? 1 minus q. So this is 1 minus 2 by 3. So which is equal to 1 by 3. Okay, so P is equal to 1 by 3. So what will be the function? I just have to substitute. No, I also need n. Okay, just now I have mu, which is equal to 6 is equal to n into p. So 6 will be equal to n, I don't know. P is 1 by 3. So n will be equal to cross multiply 6 into 3, which is equal to 80. Okay. So once I have that, I can just substitute in the formula f of x, which is equal to ncx, p raised to x, q raised to n minus x. So this function will be equal to, what is the value of n? 18. 18cx. What is the value of p? P is 1/3, will be 1/3 raised to x, and q is 2/3. 2/3 raised to 18 minus x. This will be your answer. Once I have the probability function, I can find the value for any value of x. Okay, so I just can put x is equal to 0, 1, 2, 3 up to where? Up to 18, because n is 18 in this question. So I can take it up to 18. Understood? Okay, so the last question we are going to do is fitting of the binomial distribution. Where do you want to take common? No, there is a equal to sign, Bhargavi, in between. Yes. Okay. Yes, Gurleen, understood? Excellent, excellent. Shivangi, understood? Yes. Yes, Ashpreet, very nice. 18 1 by 3. Excellent, excellent. Yes. Okay. So sometimes like Ashpreet and Vaishnavi, how you've written they may ask you in that terms, or they may ask you in this term. Okay, they may ask you this whole thing, or they may just ask you B of. Okay, so you can write this as this is a binomial distribution of 18, 1 by 3. Okay, so both are correct answers. It will depend on what options is given to you. Now, fitting of binomial distribution means what? See, I have done an experiment and then I have a frequency distribution. Okay. Now, this is based on the actual experiment that I did. Now, I want to fit a binomial distribution to this results. Why do I do that? So that I am able to predict. Okay. Once I know a model, then I can use the model to predict. What will happen when now if I've done this experiment for n is equal to 6, what will happen when I change n to 15? What will happen when I change x to 10? So all these things I would want to know. And so that is why we use what is known as fitting of the binomial distribution. Okay. So in fitting of the binomial distribution, this is used to estimate the parameters of the probability distribution, and the most common is a method of moments. Okay, so this is a theory question also. So this comprises of equating p moments of a probability distribution to p moments of the observed frequency distribution. Okay, so what we are doing, we are trying to equate the p moments of probability distribution to that of the actual frequency distribution that we have obtained by actually doing that experiment. Okay, so this is not required, where p is the number of parameters to be estimated. Okay, for a binomial distribution you have to estimate two parameters, which are those n and p. Okay, n is the total number and p is the probability of success. So the theory question that can come is the method usually applied for fitting a binomial distribution is known as the method of moment. Method, not method of least square, not method of probability distribution, not method of deviation, but method of moments. Okay. Now let us take the sum. This is the 16.6 sum on page 16.7. Fit a binomial distribution to the following data. So x is 0 success, 1 success, 2 success, 3 success, 4 success, and 5 success. So that simply means n is equal to 5. And then frequency. How many times did I get 0 success? 3. How many times did I get 1 success? 6. And so on. So here, what is the total? What is n? What is n? This is small n. Okay, this is small n. This is capital N. That is frequency, and this is equal to summation f. Okay, so how much is this? 3 plus 6 plus 10 plus 8 plus 3 plus 2. This is 32. Okay. Okay. So when I am doing the experiment, the one time when I do the experiment, so what happens is I can get a maximum success of 5 times. 5. Okay, I can get a maximum success of 5. But when I do this experiment, how many times do I do this experiment? 32 times I do this experiment, and I got a frequency distribution. I did this experiment 32 times and I got the frequency distribution. Now I want to make a binomial distribution to fit into this frequency distribution. So for that, I am going to find the moment. So what I do is, instead of p, normal p, what I do, I write it as p cap or p hat. Why do I do that? Because it's an approximation. It is not p actual, but it is an approximation. How do I find this p? This is equal to x upon n. X upon n. Okay, so this is the important thing that you should remember. Then once I have that, the fitted binomial distribution, this fitted binomial distribution will be given by same thing, but instead of p, I have a p cap. So instead of q, so q will be equal to, that is again q cap will be equal to 1 minus p cap. Okay, this is the only thing you have to remember, that this is small n. This is small n, which is equal to 5, and capital N, which is equal to total frequency, which is another figure. Okay. So once I know that, I can now find out this is X bar, sorry. So for this, what I need to do is I need to find the mean of the given distribution. This is a normal frequency distribution. I need to find the mean. So what will the mean be? Okay, what will the mean be? Mean will be equal to X bar, which is equal to 0 into 3 plus 1 into 6 plus 2 into 10 plus 3 into 8 plus 4 into 3 plus 5 into 2 upon 32. Where did this come from? X bar is equal to summation fx upon summation f. Okay, this formula for X bar, I have used this, and this is equal to how much? This is equal to 16.6. What is the mean equal to? Six plus 20 plus 24 plus 12 plus 10, 72 divided by 36, 72 divided by 32, 2.25. Okay, so I've got X bar as 2.25. Okay, now I can find out P cap. P cap is what? X bar upon N. How much is X bar? 2.25. How much is my N? Small n? Small n is 5. So 2.25 divided by 5 is how much? 0.45. Now I've got P cap. What will be the value of Q cap? 1 minus P cap, which is equal to 1 minus 0.45, which is equal to 0.55. So I've got the value of P cap. I've got the value of Q. So for the given question, N is how much? 5. P cap is how much? 0.45. Q cap is how much? 0.55. Okay. Now I have this. I can form the probability distribution. Okay. So this probability distribution will be now. Okay. So here I have my X values is 0, 1, 2, 3, 4, 5. I have my frequency distribution that now is 5cx, 0.4 raised to x, and 0.6 raised to 5 minus x. So n is 5, p is 0.4, and q is 0.6. Okay. And this I substitute. This should be. They have rounded off here, but we can use the which we have obtained also. So this is 5cx. This will be 0.45 raised to x and 0.55 raised to 5 minus x. But for your ease, they have given 0.4 and 0.6. Okay, so that you can easily do it. So here you will have to. I will just show you for one. See, remember why this happens is that you simply need to understand why this has happened or how you fit a model. You will not get such a big sum, okay? You will not get a big sum, so don't worry about that. But you must know what it means by fitting a binomial distribution to a given frequency curve, okay? So when I substitute this, the values I'm getting here is, I will just show you for one. So this is 5C0, 0.4 raised to 0, and 0.6 raised to 5 minus 0 is 5. Okay. Once I solve all this, the values that are given in the book are 0.07776. Then this becomes 0.25920. Then 0.34560. And this is given to you as 0.23040. This is 0.07680, and this is 0.01024. Remember that when you add all these frequencies, that frequency total should come to 1. Okay. this you must remember that the frequency totals, this is not frequency, rather the probability totals should come to 1. This fx totals should come to 1. Now expected frequency means what? This n has to be multiplied by this probability. So this n is 32. 32 when I multiply by 0.7776 gives me what? Just let me show you for one. 32 into 0.01236. So this is 2.48, which is nearly equal to 3. Okay. Now I have to compare it with the observed frequency. When f is 0, what have they given me? When f is 0, this is 3. 3, 6, 10, 8, 3, 2. So this is 3, 6, 10, 8, 3, 2. Okay. Now when I multiply this 0.25920 into 32, I get 8.29, which is nearly equal to 8. Then 0.34560 into 32, which is equal to 11.05, which is nearly equal to 11. Now 0.26040 into 32 gives you nearly equal to 7, and 0.07680 into 32 gives me 2.5, which is nearly equal to 3, and 0.01024 into 32 gives me nearly equal to 0. Now remember, this addition should also be equal to 32. So this 3 plus 8 plus 11 plus 7 plus 3, let us see. 3 plus 8 plus 11 plus 7 plus 3 is 32. So this is correct. Okay. So expected frequency total is also 32. Observed frequency is also 32. Now you compare. This is my probability distribution is giving me the value of 3. Actual observed is also 3. Here it is giving me 8, here it is giving me 6, 11 and 10, 7 and 8, 3 and 3, and 0 and 2. So they are very near each other, so that whatever probability distribution I have fitted to the observed frequency is a correct one, okay, is a good one. So this is how you fit a binomial distribution onto the given frequency distribution, okay. So I think we have already overshot our time. So I hope you've understood and enjoyed the session. Just put it in the chat box whether you've enjoyed the session or not. So thank you for your patient hearing and have a great day. And on Monday we have Ghatasthapana, so the start of Navratri. So wishing you all a very happy Navratri. Thank you so much.